Hi, today's topic is factorization, and I know most students slightly tend to freak out when they think about factorization. However, it is actually quite simple once you get to understand the concept of what factorization means. So, just to quickly summarize, we have a highest common factor. We can factorize through grouping, which is just an extension of the highest common factor. And then the more tricky one of all the options we have is factorizing trinomials. And the reality is, what factorization is that we essentially just look for factors. So for example, if we have the number 10, and we want to know what are the factors of that number. Well, factors mean that we want to break that number down into smaller numbers than 10 that when multiplied together give me 10. So in this case, 1 and 10 are factors, and 5 and 2 are factors. So 1 times 10 will give me 10, and 5 times 2 will give me 10. Easy enough to understand. As soon as we get to algebraic, so now if we have something like 4x, what are the factors of 4x? Well, firstly, we break the number up and we say, okay, well, what are my factors of 4? Well, they are 2 and 2, or they are 4 and 1. So that's dealt with now, the coefficient, the number in front of the variable. But we still need to deal with factors of this variable. So what times what gives me x? Well, anything times 1 will give me that number. For example, 4 times 1 is 4. So 1 times x. So x becomes a factor of x. So those are my three factors or possible factors of 4x. If we move on and we have a look at something like 2x plus 2. Well, now we've got a monomial. So here we have a binomial, which is one term, an additional subtraction, and another term. So if we are looking for a highest common factor, so what a highest common factor is it says that we are looking for something that is common to both terms, or to all the terms in that polynomial. So in this case, we can clearly see that 2 is in this first term and 2 is in the second term. So what we do is we factorize, or we take it out as a common factor. So I take it out and I put it in front of my bracket. So now what I'm left with is, if this 2 disappears or I factorize it out, all I'm left with is an x. Plus, now if I take out a common factor of 2, so what we mean by taking out a common factor of 2 is actually we divide. So 2 divided by my common factor 2 is then 1. And this is now in factorized form. So what factorizing does is it shows us multiplication. So here we have two terms showing addition, and we shuffle them around, or we do some sort of a mathematical procedure so that we end up with multiplication. This says 2 times what's inside my bracket. Let's have a look at another example. Something, let's go with 3x squared plus 6. Okay, so if we have a look, we know that 3 is common to both of these, because what that 6 is actually 2 times 3. So here we can see that there is a 3 in here and a 3 in there. So if we take the 3 out, I'm going to be left with x squared plus, and we said that factorizing was a division, so 6 divided by 3 gives me 2. Easy enough. If we extend that example, 3x squared plus 6x, well, we know that from the previous slide we took 3 out as a common factor and we were left with 2x plus 2. But now, if we're going to look, we've said 6 divided by the 3 gives me the 2. And we take what's left over and we leave it behind. But now, if I look and I say, okay, well, we need to take out the highest common factor. So we take out a number, but we can also take out a variable as a common factor. So if we look here, we have x squared and we have an x. This x squared is actually x times x. So here I have 2 x's and here I have 1. So I can take out one of those x's, leaving me with 3. Once again, division, so x squared, if I have 2 of them and I take 1 away, I'm left with just 1x. The 2 stays, and now if I have x divided by an x, leaves me with just 1. So 2 times 1 is 2. Now that is my factorization. I have factorized out a common number out of both my terms, as well as a common variable out of both my terms. So the next topic in factorization is grouping. And grouping generally means that we are going to group some terms together and find a common factor in there. The reason for that is because if we have a look at this polynomial here, we can see that 2am plus 3m plus 24p plus 16ap has no single common factor. 2 cannot go into 3, it could go into 24 and into 16, but it doesn't go into all 4 of my terms. So what we want to do is we want to divide this polynomial with 4 terms into 2 smaller sort of things that we can work with that have common factors. So for instance, these 2 over here have a common factor of m, and these 2 have a common factor of p. However, it's not just the p that is common. We also have this coefficient of 24 and 16, and we know that, well, the common factor there needs to be, or can be at least, factors of 24 are 1 and 24, 2 and 12, 6 and 4, 8 and 3, 16 is then obviously 8 and 2. So what we could do is we could say common factor of 8. So what we do is we take out our common factor m, and what's left over is then the 2a plus 3. Let's just get that in the same color. Then we say plus, we take out our common factor of 8p. Now what's left over is, well, 24 divided by 8 leaves me with 3. P divided by p leaves me with 1. And so then we add our plus. Then 8 goes into 16 twice. And if I divide my p's, AP, the p's will disappear because p divided by p is 1, leaving me with only an a. Fantastic. So now we have grouped our terms. We've grouped these two, found a common factor of m over here, found a common factor of 8p. But now there's one more step that we need to take into account. And that is that what we've actually done is we've created a common bracket now. So that common bracket, once again, we can take out as a common factor. So like we did with the m, we put what's common in the front, so it's 2a plus 3. And we put the brackets to show, well, that was the bracket we took out. And what's left over is then my m and my 8p. So that leaves me with m plus 8p. And that is how we factorize through grouping. I hope that has made a bit of sense to you. Let's maybe have a look at one more example just to clarify. Let's get us another. Here's another example for us to have a look at, just to cement our understanding of factorizing using grouping. So here we have mx minus my minus nx plus ny. So we have 1, 2, 3, 4 terms. So we use grouping when there are quite a few terms in our polynomial. And especially when that polynomial doesn't have a single common factor across all of my terms. So what do? We divide them into 2 so that maybe there's a common factor in 2 terms, and then we can progress from there. So if we have a look and we say, okay, well, over here my common factor is m, and over here my common factor is n. So let's factorize. So if we take m out as a common factor, that leaves us with x minus y. Oh, let's keep that same color. Then we're going to say, so this is what I would like to do. Because of this minus, it makes it a little bit tricky. So what I would do is I would put a plus there, keep my bracket, and then I would say minus nx plus ny. So now what I've done is I've actually created some sort of a thing that looks like it's been factorized so that I can see exactly what my common factor is. And over here is an n, or a minus n should I say, and a positive n. So let's carry this down. We say m into x minus y plus, and what did we say our common factor was? Well, we said it was n, and what's left over after I take away my n? Well, here would be a minus x plus y. Let's just make this the same. Okay, so what we've done is we've hopefully created a common bracket. So let's have a look. X minus y minus x plus y. So that's not actually a common bracket as of yet. The only reason it's not common is because of my signs. So what we need to do is factorize out a negative. So if I factorize this negative out, I end up with, so let's see, if I take this minus x plus y and I take a negative out of there, what I can do is actually I change this sign and it becomes a negative. So that becomes a negative. This becomes positive, negative. So what I'm actually doing is I'm dividing a negative out as a common factor, just like we did with the n and the m. So what we can do is then we can see that this becomes m into x minus y minus n x minus y. Now we have created our common bracket. Let's just add a new script. So what we've done is we've ended up with m into x minus y minus n x minus y. And we said that this x minus y was our common bracket. So what do we do with common factors? We put them in the front and we leave what's left over. So in this case it would be an m and a minus n. So we'll have m minus n. And that, ladies and gentlemen, is your factorized polynomial using grouping.